Learn how to safely decrease numbers in a shared multi-threaded memory using atomics. Here's my boilerplate script, and in this lesson, we're going to be making an example that demonstrates how we can securely subtract and use it to demonstrate that our operations modify our array while returning the subtracted value back to us. And if you look at what I have on the screen, I currently don't have much inside my HTML section. So I'll move straight into my script section and then begin to write the necessary code for the example. Now, in your normal traditional JavaScript, when you have something like this, and let me say minus equals 1 or any value now, and then you try to output this count value into the console. Now, if two background threads try to subtract from the same count, assuming that you have two background threads that are trying to subtract from the same counter as an example that you can see on the screen, and they are trying to do it at the same time using the standard math method of what I have here on the screen. They can collide and then calculate the wrong total. So because of these errors that is likely to happen if they collide, that is where atomics comes in, because atomics helps to isolate the memory slot, and so it drops the value by your exact number in a single unbreakable step. So instead of breaking the step, everything will happen once in a single step, thereby eliminating the need for error or collision in your code. So to moving on rather. So the example that I want to use in this lesson, I want to add a comment to it. And the first thing I need to do is that I need to set up a shared buffer that you can work with in this example. A shared buffer. And how do I set a shared buffer? Well, I'm just going to make a variable. So let me just say const shared buffer. Or let me just call this buffer. And so I can call the shared array buffer constructor. Shared array buffer. And inside this array buffer, I want to create 4 slots of memory divided into 4 bytes each. So I'll just call the slots and then call int 32 array constructor as well dot bytes per element in order to calculate the number of bytes in each of the memory slots. So having done that, so I'm going to make another variable and call this shared buffer as well, and I will call the new int 32 array constructor as well, and then pass in my buffer variable inside of it. So once I have done this, it is now time for me to initialize the starting benchmark value for my code. Initialize the starting benchmark value. So, and how do I do that? Well, just make another variable. No, I'm not making variable. I'll just call the shared buffer, which is my variable that I have here, and then allocate a starting slot to it. And then let me just give it a value of, say, maybe 10. So now that I've done this, it's now time for me to perform the thread subtraction. It's now time for me to perform the thread subtraction of my code. Using atomic. So how do I do that? Well, it's just very simple. So let's say I make a variable and call it old value. And inside this variable, then I'll call this atomics. And this method, the subtraction method, a shorthand for subtraction is this sub. And then inside it, I will pass in my shared buffer, which I have here for initializing the memory slots. and then I'll pass in an index position and a value. So in my case, let's say I pass 4. So I can then go ahead to output the result. And how do I do that? Well, console.log. Then I can call and say, oh, then this would be my load value. Load value. And then you can make another one and call it console.log. And say, okay, new and call shared array buffer at the index position of 0. And this, as you can see, should log 6. Now, so this is what is happening. Now we have our shared array buffer here initialized to 10. So this code value is going to be 10. Sorry, shared array. It's actually shared array. Shared array. Because I'm assigning a value at an index position, so it's an array. So what is going to happen here is that I missed this as well. This also should be shared since I'm making an array, not a buffer. I've already made buffer here. So if you look at what I have here, the initialized starting benchmark value is 10, and that is going to be the value of our old value that we have. If you try to output the result, why the new results is going to log 6. Shared array. So, and then this is going to output 6 for us. And why is it going to output 6? So it's just going to subtract this 10 from 4 that we have here, and it will give us a log of 6. But currently, I'm not going to be able to see the output in my console because of my browser trying to protect interruptions to my system memory. So by default, it's blocking this shared array buffer constructor, so it will not allow it to run. But there's a workaround it. You can just check online for how you can disable that in your browser, and then you'll be able to see the results in the console. So this is how now you can use atomics to perform a simple operation that prevents deletion or breaking of counter in your code. So you can use it to safely decrease number in a shared multi-threaded memory. And if you do this by isolating the memory slot and then drop the value of your exact number in one unbreakable step. So this is the usefulness of using atomics alongside decreasing of numbers in a threaded shared memory.